All right, so now we're going to focus on inverses. And I understand that the term inverse, maybe this is a little bit confusing because, we hear words like inverse, reciprocal, and opposite. And in mathematics, those all have very specific meanings, none of which are the same. However, in our everyday language, we might, in certain instances, use those words a little bit interchangeably, maybe not appropriately, but usually it'll still get our message across. But in mathematics, they mean something very specific, and it is not the same. So today we're going to focus on inverse. All right, first thing, let's do this together, and then I'll explain why afterwards, or why we did what we did. So if f of x equals 2x plus 3, the first part is I want to solve this function, which remember f of x is the same thing as y, that's all this notation says, for x. So what I'm going to do is I'm going to first subtract 3. And then I'm going to divide both sides by 2. And so I end up with f of x minus 3 over 2 equals x. Now, that's part A. Lovely. The reason why I did that is because part B says find the input when the output is -7. So remember, when we have a function, this function notation is telling me x is the input and f of x is the output, or y is the output. So this is saying, for part B, the output is -7, find the input. And so that's why we solved for x, so that x is by itself. So if I plug in something for the output, I can find the input. So we'll do that, and we can say -7 minus 3 over 2, and -7 minus 3 is -10 over 2, and so I have -5 equals x. So that is part B. This is going to make more sense in a little bit on why we did this. So first, we want to make sure we understand how to do it. So I want you to do number 1 and number 2, similar sort of process. Solve for x in both instances, and then find the input or inputs when the output is 2. Pause the video, do that for 1 and 2, unpause when you're ready to discuss. Okay, so the first one here, I added 2, so that was pretty straightforward, hopefully. F of x plus 2 equals x. All right, that was the first part when we solved y equals f of x for x. Then we plugged in 2 for the output, so 2 plus 2 is x, 4 is x. Great, nice. For the second one, first thing I did was I isolated the x squared, so I divided both sides by 2, so f of x over 2 equals x squared. I want to get rid of the square, so I take the square root of both sides, and I need to remember to do plus or minus. So x equals plus or minus the square root of f of x over 2. That is the first part, and now I'm going to evaluate when the output is 2. So I'm going to do this 2 separate times, once with positive root 2 over 2 and once with negative root 2 over 2. So I plug in the 2 for f of x, simplify, 2 over 2 is 1, the square root of 1 is 1. So this, since it had the negative in front, becomes a -1. So we get x equals 1 and x equals -1. Okay, nice work. All right, so now I know that the burning question in your head is, wait, he's been talking about inverses, or he talked about inverses at the beginning, but hasn't mentioned an inverse since we've done either of these first couple of examples. So what's going on? Am I watching the right video? Is this the same math that I'm supposed to be doing? Yes, it is. So this is leading to exactly what we're going to be doing, and that is understanding the relationship between a function and its inverse. And that relationship is that the input and output switch. So we switch what is the input and we switch what is the output. That is the relationship between a function and its inverse. Literally, if you were to graph a function, and we're going to see this, and you were to graph its inverse, you would switch all of the x and y points. That's what you do. Okay, so let's do this. So to find an inverse, the first thing we're going to do is we're going to switch the x and y. So remember, f of x is the same thing as y, so I can think of this as y equals 3x minus 1. So now my first step is to switch x and y. So I'm actually going to say x equals 3y minus 1. Great. Now solve for y. So x plus 1 equals 3y. Divide by 3. X plus 1 over 3 equals y. So this is going to be the inverse. Now, notation. This is going to be something that's very important to understand and recognize. How we're going to write our answer is going to be f to the negative 1 of x equals x plus 1 over 3. So this right here is inverse notation. That f to the negative 1. Anytime you see that, that is not saying that this is a function raised to the negative first power. That is saying inverse. It's really crucial that you understand that because otherwise it's very confusing. And the reason why we're still using f is because now this is specifically saying, okay, this is the function f, this is the inverse of f, right? If this was g inverse, then it doesn't relate to this function. So this is the inverse of this function. Now, if we went the other way, it would also be true, right? If this was the original function, then this would be the inverse. And so I would change the notation. But that's what this little negative 1 is going to say. So anytime we see that, we need to understand that means inverse. And so again, going through the process, how did we find the inverse of the function? We switched the x and y, and we solved for y. So what did that do? Well, graphically, it switched all of the x and y values. All right, so I want you to try and do this for a and b. Find the inverse of each function. Pause the video. I'm pausing when you're ready to check. All right, so for a, first thing I did is I switched the x and y. So instead of f of x equals negative x plus 1, I say x equals negative y plus 1. And if you are getting confused because here I'm writing y and here it's f of x, remember those are interchangeable. And if you prefer, just leave it as f of x. That's totally fine. So then I subtract 1, and I get x minus 1 equals negative y, and then I divided both sides by negative 1, so this became negative x plus 1 equals positive y. Then I just rewrite using my inverse notation, so f inverse of x equals negative x plus 1. Great. For b, first thing I did, switch the x and y. Then I added 2 to both sides, so I had x plus 2 equals 1/3 y. That was the purple. And then to get rid of the 1/3, I multiplied both sides by 3. So that's what I'm doing in the green here. Now I do have to remember to distribute that 3, so that's why I put parentheses around the x plus 2. So when I distribute the 3, I get 3x plus 6 equals y. So then f inverse of x equals 3x plus 6. Now you know how to find the inverse of a function. Okay, so the next thing we're going to talk about is, well, is the inverse of a function always a function? And does a function always have an inverse? Well, yes, kind of. So what we have is what's called the horizontal line test. And what the horizontal line test does for us is it will determine if we know something is a function already, will that function have an inverse that is also a function? If the original function passes the horizontal line test, then that is true. Yes, it will. The inverse of this will be a function also. If the original function does not pass the horizontal line test, then the inverse of this function will exist, but it won't be a function. And keep that in mind. Actually everything we've done so far this year has been dealing with functions. But there are many things in mathematics that aren't functions. And not everything has to be, right? But it's really important if we know something is a function, then that meets specific definitions and guidelines that can help us. So how does the horizontal line test work? Well, we can see from the graphic here, and also if you've read this since I've been talking, if a horizontal line touches the original function more than once, then the inverse will not be a function. If it touches only once, and we have to keep in mind, we have to be able to move the horizontal line everywhere, right? So if there's one place, so for instance, if I had a function that was like this, right? Well, if I draw a horizontal line right here, it only crosses once. But if I take that horizontal line and I move it down here, well, now it crosses 3 times, right? Or here, it crosses 3 times. So if it fails at any location, then the inverse will not be a function. So let's do an example. Consider the function f(x) equals 2x to the third plus 1. Determine whether the inverse f is a function, and then find the inverse. All right, I want you to try this. How to determine whether the inverse of f is going to be a function. Use your calculator and graph this and look at it. Pause the video. Unpause when you're ready to check. All right, so first thing, is it a function? Is the inverse a function? Yes. So again, I did this on my calculator. So if I go to my calculator, y equals 2x to the third plus 1. I looked at the graph, and I can see that it doesn't look like if I was to draw a horizontal line anywhere, that it would cross the graph more than once, right? So yes, it meets that definition. So then find the inverse. So I switched the x and y, solve for y. So I subtracted 1. I divided by 2. Then I was left with x minus 1 over 2 equals y cubed in purple. So then I did the cube root of both sides in yellow. Remember, if it's an odd index root that you are doing, you do not need the plus or minus. It's only on even index roots. And here the index is 3. That is odd. So I get the inverse is f inverse of x, the cube root of x minus 1 over 2. Nice work. All right, so what do we understand about inverses? The relationship between a function and its inverse is that all the x and y values are switched. So what does that mean? Well, that means if I want to find the inverse of a function, I literally switch the x and y variables and then just solve for y, and that is my inverse function. To determine if the inverse of a function will also be a function, we use the horizontal line test.